Shaping the future is in our DNA. With Tebis Next 40, we envision a spaceship from the year 2065 that redefines the future of manufacturing. Follow its journey from the first concept to the final exhibit.
Mein Name ist Jan, ich habe den Design Contest.
My name is Jan. I won the design contest that Tebis organized in collaboration with Pforzheim University.
Also der übliche Designprozess ist, dass man...
The typical design process begins with inspiration. It is one of the most important elements of all, because every design is based on something, whether it's a model from nature or something that already exists. For the basic shape of my design, I drew inspiration from a shark fin. In the side view, you can see the two fins in different sizes. It was important to me that the upper and lower wings not have the same proportions, but rather be differently shaped, just like a real shark fin. The main feature of my design is the twisted shape on the front of both wings. When asked which task required a particularly high degree of precision, the answer is
Das war vor allem bei mir das
above all, mirroring during the clay modeling process. It's not all easy to mirror a vertical object, because there are no clear reference points. That's why I actually hung a plumb line in the room and used it to mirror the two sides while I was working on the clay model. After scanning, the winning design is available as an STL file and is uploaded to Tebis via an interface. The challenge now is to generate a precise surface model from the mesh model that faithfully reproduces the characteristic shapes and sharp edges.
Auf diesem Netz werden als erstes
Curves are first generated on the mesh, which define the size and dimensions of the future surfaces. Within these curves, the actual surfaces are then constructed using surface functions. The shark fin is already clearly visible in profile.
diese Flächen
These surfaces initially still have a slightly wavy structure, which originates from the mesh model. Using surface modeling, the meshes can be refined and given a more homogeneous surface profile. This is how the first surfaces derived from the mesh are created.
So haben wir jetzt unsere ersten Flächen.
Reverse engineering in Tebis is structured as constructive reverse engineering. This means that the various areas of the surface are represented as much as possible by large, clear and cleanly structured surfaces.
Von dieser Oberfläche soll nach Möglichkeit in großen und klaren Flächen.
When asked what comes after reverse engineering, the answer is
Auf Basis dieser Flächen
the actual design process.
die Konstruktion
Since the model cannot be milled as a single unit,
abzufräsen, also so müssen wir das
it must be broken down into individual components.
Einzelteile zerlegen, die ganze Führungen
Guides, bolted joints and connections are designed so that, when assembled, they form a closed and high-quality overall shape.
komplette saubere Einheit. Als erstes wurde hier
First, the individual assemblies are derived. The cockpit is given an opening, which will later be closed again, and the wings are designed as separate components.
Öffnung oben, die wird auch wieder zugemacht. Das sind jetzt einfach mal Einzelteile und wenn man mal so die
The connecting elements and screw joints must already be accounted for on the individual components.
Elemente, wo die Teile miteinander verbunden werden, die ganzen Verschraubungen zueinander müssen geplant sein. Hier im unteren Bereich der Flügel, auch das muss alles.
At the same time, care must be taken to ensure that the exhibit can be easily assembled later and that all screw connections remain easily
Da
accessible.
muss man halt einfach ein bisschen darauf achten, dass man an die entsprechenden Schrauben und an alles gut hinkommt. Nach der Kanzel werden im Endeffekt dann
The wings are then assembled and screwed to their corresponding guide components.
den ganzen Führungen, die werden dann einfach montiert und entsprechend mit Schrauben verbunden. Das Modell ist hier jetzt auf dem
The model is partially rendered transparent to reveal the internal structure and material cutouts.
Material, wo herausgeholt wurde, auch dargestellt wird.
The same principle applies to the lower wings as well. From the outside, however, the structure remains completely closed. Screws or fasteners will not be visible once the model is assembled. So where are the greatest design challenges for our Tebis Next 40 spaceship?
Gerade in diesem Teil sind natürlich die
The greatest design challenges for our Tebis Next 40 spaceship lie in the design's distinctive character lines. These dominant lines must not appear wavy or uneven. Rather, they must follow a clear and consistent path so that the design can make its full impact. Achieving this surface quality required a great deal of time and care. These areas will also pose a particular challenge during milling.
Für die Fertigung stehen uns dann gleich
For production, we are supported by 4 partners: FTS System with its zero-point clamping systems, Ingersoll with tools for drilling, milling and turning, as well as machining centers from Okuma Europe and DMG Mori Seebach.
und DMG Mori Seebach.
The key feature here is the perfect digital representation of our partners' components within the Tebis CAD/CAM environment.
Wir sprechen hier
We are talking about a digital twin that enables reliable and precise manufacturing.
präzise Fertigung möglich wird.